So we're going to solve those equations. We're going to solve some absolute value equations. We're going to solve some rational equations. So what you'll notice as we go through college algebra is they combine a lot of different things. So instead of having one section for each different type, they're going to do all of them together. Okay. So to start with, we have to do a little terminology. So we have to talk about what it is an equation. Okay, so we have to be able to solve it. So when we solve it, we're finding the solution, or what's called the roots. So when we're finding the solution, we're trying to find what values are going to make this a true statement. Okay, so what values are going to satisfy the equation to make it a true statement? Now, when we're finding these solutions, you can get different types of solutions. You could get a set answer. You can get infinite answers. Maybe you get no solution or no answer. So what we do is we classify these in 3 different ways. So a conditional equation is an equation that is solved by at least one real number. So it has one solution, or maybe it has 2 solutions, but it can't have infinite solutions. It has a set number of solutions. So for instance, a linear equation, we usually have 1 solution. A quadratic, we could have 1, but we could have 2 solutions. So it has a set number of solutions and not infinite solutions. So that's why it's saying it cannot be an identity. An identity is the second way that we classify this equation, and that's when it has an infinite number of solutions. And the last one, if you have no solution, there's no values that will satisfy it, it is considered an inconsistent equation. It has no solution. So each time you're asked to solve an equation, you'll solve it, but then you'll also classify it. So when you classify, you're going to classify it in one of those 3 ways. It's either a conditional, an identity, or it's inconsistent. Is everybody good? It's hard to know where everybody's at when you can't see everybody. All right, so here's our first example. So solve that equation. So bring back your math brain and solve that equation. So most of you probably got through this fairly quickly. We need to add 3 to both sides. So we're going to add 3 to both sides. And then we would have 5x equals a negative 10. And x is a negative 2. Now, we have solved it. We found a solution. Now we have to classify the equation. So would this be conditional, identity, or inconsistent?
Conditional.
Conditional. So again, you're going to have pretty much kind of two solutions or two answers. You're going to have your actual solution, and then you're going to classify it. If they are doing this in web work, it may be two separate parts. So part A, you would say x equals 2, and the next one, maybe it's a multiple choice and you select conditional, identity, or inconsistent. So go ahead and try this next example. So the first thing that you probably would have done here is your distributive property on the left-hand side, which would give you 3x plus 18 equals 3x plus 18. What do you notice about both sides of that equation?
They're the same.
They're the same. Okay, so you could subtract 18 from both sides if you needed to, but you still get something that is the same. So when you see that, you can plug any value in for x and it would satisfy that equation. So we would actually have infinite solutions. And then how would we classify it? The equation is in
Identity.
identity. Questions on that one?
Yeah, what's identity mean? Maybe I don't remember this, but.
It means you have infinite solutions. It means you can plug any number in for x and it would always be true. So I could plug.
So identity is just a synonym for infinitive?
Okay, so when you, this part is your actual answer, like your solution. And this is classifying that type of an equation. So an identity is an equation that has infinite solutions.
Okay, gotcha. Yeah.
Okay, try to solve this next one. We're gonna add a little fractions in. Okay, so when you solve this, there's several different ways you could solve this. One way would be to multiply both sides by the reciprocal. So you could multiply both sides by 3/2. If my pen's gonna work. So then your 3/2 and your 2/3 would cancel, and you would have x equals -27/2. Again, -27/2 would be your answer, your solution. Is it showing that I wrote anything on your screens? I think it dropped
Oh.
again. All right. We will try again. There you go. All right, so again, negative 27 over 2. And because it has a particular solution and not infinite solutions, this would be conditional. Another way you could solve this is if you left this here, multiply both sides by 3, you could get 2x equals a negative 27 and solve that way. It doesn't matter, whatever works for you is fine. So let's look at the next one. Go ahead and try to solve, please. Okay, so if you're working on this one, combine your like terms on the left-hand side, which is going to give you 5x equals 5x plus 1. We can subtract our 5x from both sides. So we would have 0 equals 1. What do you think that's going to mean?
No solution,
Consistent.
inconsistent.
Correct. No solution. And we would classify that equation as inconsistent. Okay. Now let's throw some more fractions in there. So there's a couple different ways you can approach this. If you're comfortable with leaving them in fractions, you can leave it in fraction form and solve. If you would rather not do that, you can also get rid of all your fractions by finding the common denominator. So if you have 2, 3, 4, and 6, what is your common denominator?
Oh,
12. So what you're going to do is you're going to take everything in your equation, you're going to multiply by 12. So be very careful when you're doing this because you have to multiply every coefficient all the way through. So we're going to take 12 times our 3 halves x, which is equivalent to saying 12 times 3, which is 36, and divide it by 2, which is going to give me 18. So we'd have 18x. Take our 12 times our negative 1/3, we get a negative 4. And take your 12 times your 1/4, which is really 12 divided by 4, which gives me a 3x. And then 12 times a 1/6, which is going to give me a 2. Then we need to get all our variables on one side, all the numbers on the other side. We're going to subtract our 3x here. So we'd have a 15x minus 4 equals 2. Add 4 to both sides. 15x equals 6. So x equals 6/15. Now, when you are in WebWorks, you cannot enter in 6/15. Why not?
Not simplified enough.
It's not simplified enough. We would need to reduce this. If we reduce this, we would have 2/5. So make sure when you're in WebWorks that you're entering a simplified solution. Also, make sure that if it's asking you to round to 2 decimal places, that you're doing that. So be careful and make sure you're following their instructions so you don't miss questions just because you made a simple error. Now, we did get a solution of 2/5. So if we were to classify this solution, what would it be?
Conditional.
Conditional.
Lavelle, you have a phone call in the office. Lavelle, you have a phone call in the office.
Questions on any of the examples that we've looked at so far? The next one here we're gonna do, it's just dealing with decimals. Again, you can get rid of all your decimals if you want. We could multiply everything through by 100 if you wanna get rid of the decimals. If you don't mind dealing with the decimals, you can just leave them. And that's kind of how I'm gonna approach this one. Again, we need all the variables on one side, the numbers on the other side. So we're gonna subtract 0.27x. Again, it doesn't matter what side you go with, you'll still get to the same answer. So we have -3.9 equals 0.22x plus 0.29. Subtract our 0.29. So we'd have 0.22x equals -4.19. And then divide both sides by 0.22. So if you have a calculator, let me know what you get.
-19.045 repeated.
Okay. Now you won't be able to put the repeat on the WebWorks. You would have to just read the directions and look at what it says to how to round it. Again, we did come up with a solution. So again, this one would be conditional. Questions on this one? Okay, this example shows an example with a square root already in the problem. I would give you the suggestion not to type in the square root of 38 in a calculator and get a decimal approximation. Leave it as the square root of 38. So you're gonna solve it just like you would solve a normal equation. You're going to subtract your 4 from both sides. You would have 3c equals, my suggestion would be to write this as -4 plus the square root of 38. Some of you might want to write it as square root of 38 minus 4. That's fine, but sometimes what happens is you kind of extend that square root and it's hard to tell what's under the square root and not. You can fix that by just putting that -4 in front. You'd finish solving for c by dividing both sides by 3. And then the solution that we got here is what we would consider our exact solution. So it's exact. We have not rounded anything. We didn't plug anything in our calculator and get an approximation. So that would be an exact solution. If we type this in our calculator and we get a decimal approximation, that would be an approximate solution. So again, you would need to see what kind of solution are they asking for in the WebWork. Are they wanting a decimal or are they wanting an exact? Again, we got a solution, so this would be considered a conditional, oops. Conditional equation. Is everybody okay with the exact versus the approximate? I'm going to assume you're fine. So the next part of the lesson, we're going to talk about solving rational expressions or rational equations. The hint that's given here is when you are solving these equations with rational expressions, is to multiply all the terms by the common denominator. Similar to what we did earlier when we dealt with just the fractions, we multiplied by the common denominator. You would do the same when you're dealing with rational expressions. So here's our first one with a rational expression. So this one's kind of more similar to what we did when we did the fraction example earlier. So if we think of what the hint said multiply by the common denominator. So again, here we would need to look at our two denominators and we need to find the common denominator. What would our common denominator be?
Ten.
Now, the biggest mistake that's made is you will multiply by these first two pieces, but you'll forget the one that's over here by itself. So be very careful and make sure you multiply every single piece by that common denominator. So when I do that, I'm going to rewrite it, and you may not need to rewrite it. You can skip this step if you want to, but some people need to see it. So I'm taking 10 times y plus 4 all over 2, and then 50. So you're multiplying 10 times each one. Notice you're multiplying the numerator by the 10. And notice that I didn't divide it out. Because here, when I look at this, this is really 10 divided by 5, which would give me 2. And then I have y minus 3. Also, notice I did put parentheses here. If you don't, that's going to cause you an error later on. You have to make sure that if there's a quantity, that you put that in parentheses. The next one is 10 divided by 2, which is going to give me 5. Like I said, if you don't need that step and you can skip it, that's fine. I just wanted to show it out, work it out for those who might need that. Now we need to do our distributive property, which is going to give me 2y minus 6 plus 5y plus 20 equals 50. We need to combine our like terms, which is going to give me a 7y plus 14 equals 50. Subtract your 14. And then divide by your 7. Again, we came up with one solution, so we would say that this is conditional. So these rational ones will be a little bit more work, especially when we get farther into some a little bit more complicated examples. For right now, I think that's where I want to stop. We will continue on and finish this lesson up on Wednesday. You might want to check in WebWork and see if you can start, because you can probably get through a lot of those problems without much additional assistance, at least probably about half of them. But I would try one, get out of it, and see if it saves what you did. I don't want you to do a bunch of work and not be able to complete it in one setting and it not save. So I'm not exactly sure how that's going to work, and without somebody trying, we won't know. So if you would try before we meet again on Wednesday and see what we can have happen. Anybody have any questions on anything that we've talked about with anything or including the lesson?